Then the big piece here, so the walls are pretty straightforward. The floor ceilings can be much more complex. In this particular case, we're looking for a single layer drywall system. This is a standard system right out of the, out of the AF&PA guide, and it works for any number of different manufacturers, although all of them have their own specific ones too. And you can see that on the left we've got a STC of 51 with an IIC of 46. That's based on vinyl. And on the right-hand side, it's a little bit better because we can add some gypsum on there. Notice, however, interestingly enough, that depth is not specified on this. You actually have to go to an individual manufacturer's system that looks just like this and find out exactly what those thicknesses are to get those STC and IIC ratings. And then to add, I won't say insult to injury, but just to make it a little bit more difficult for you, obviously not every manufacturer can afford to set up every single possible combination of gypsum thicknesses, drywall thicknesses, and orientations, etc., or the different types of final finishes. In this case, we're going to put in tile and hardwood. There are some ways that you can calculate this. In fact, in this course, there's a download that you can pull off that we give you some additions, adders and subtractors that you can use to make those various modifications. They're just mathematical, and they'll get you fairly close to where you probably want to go. But let's look at the detail of this, because this is where things can really get a little bit dicey. So one of the first things is this resilient channel. So there's resilient channels, there's hat channels. Not the same thing. Okay, so resilient channels actually decouple the joist from the drywall. You can see in that little diagram there that there's attachment specifically to the joist and one to the drywall. It allows it to flex. They usually have the little slots in them too that help actually prevent noise from making its way through. A hat channel is a direct attachment. When you're out there in the field, you want to look for resilient channels. As general contractors and other tradesmen, we have a tendency to just throw out the term channel, which can mean anything, but we're very specific on this one. Let's continue. Then the joist itself. So you see here the two joists that look remarkably identical, and they are remarkably identical, with the exception of an 1/8 of an inch difference of thickness in the flanges. So the tested assembly is the one that has to be specified. In this case, it takes a full 2x4, 3.5 by 1.5 inch flange, but you can see there's a cousin right next to it that's only 1 3/8 inches thick. Now that's not by accident, it's all by design. The engineered wood industry is a very competitive industry. Flange thicknesses have been dropping for the last 5 to 10 years. So for the most competitive joists, those are out there. However, most manufacturers still maintain an inventory and continue to manufacture the full 1.5 inch thickness joist just for this reason, because there will be fire assemblies, it does need to be done, and that's the one that actually makes it work. So make sure that's the part of the specification. Then there's drywall. So day in and day out, we throw around the terms type X. We see it in the code time and time again. So it seems like that's the fire-rated type of gypsum you should be specifying. Not so fast. Again, when you get down to the nitty-gritty of specifying a product and a system, where the devil's always in the details. So type C, in fact, ends up being pretty much de rigueur. For an engineered wood floor system, for its single layer, you have to have it. The difference is this vermiculite that's added into the type C board. All it means is that that's what it took for it to pass the 1-hour assembly test. The type X obviously didn't, otherwise we would have specified type X. But it didn't. Type C worked, and what the vermiculite does is it expands slightly as the gypsum shrinks during heat. The vermiculite does the opposite. It expands, holds the board together just a little bit longer in order to pass that 1-hour test. Then there's insulation. Again, very specific. This particular system is mineral wool, and it's got to be 2.5 pounds a cubic foot. There's a couple different weights and varieties here, but as you can see in this picture, It's much more condensed. It's typically a thinner bat, maybe a few inches at the most. It's more dense, and it actually has the ability to prevent fire from coming up through the structure and from heating the elements above it and raising the heat. Common insulation, fiberglass insulation, doesn't cut it. In fact, fiberglass insulation doesn't do you much of anything. It doesn't help a whole bunch with sound, a little bit with airborne, almost nothing with impact, and it doesn't do you any good with respect to fire. Let's continue. So now we've got enough information and we know exactly what we're dealing with. Let's actually put together some details that we're going to give to the engineer. So here's I've sketched out just a real quick floor ceiling detail, again taken right off the manufacturer's website, and put the specs on there. You can see I put an STC of 50 plus, an IIC of 50 plus. The actual numbers, it turns out this specific system as we've spec'd it, of course, is not in the system. If we do the calculations, it works out to be like I think it's like a 58 or 60 for the STC and like a 54 plus or minus, somewhere in that range for the IIC. So in this case, the architect was pleased. He was able to get something a little bit better than code. And then of course, I've just left the numbers blank there with X's, but this is the time to put in those specific numbers so that you have those for your reference. The exterior wall, again, is pretty straightforward. The lower section of the wall is going to be stuccoed, 5/8 type X on the inside, bat insulation for the sound, and conventional insulation for that matter too. But if you look at the interface, now remember we had to have fire from the outside and the inside, right? So probably not too terribly worried about fire on the inside because you've got a 1 hour assembly at the bottom by 5/8 here, 5/8 here. On the upper side you've got your deck and you've got 5/8 up to that, so that's all good and happy. But that cavity in between is where you can get in some real difficulty from a specification standpoint. Simple way to do this, as this architect took out, was simply to spec a 2x equivalent, which is dimension lumber essentially. In the code is listed as fire blocking. There's a difference between fire blocking and draft stopping. We're talking about fire blocking here. As long as it's something that physically blocks the passage of fire. Okay, so instead of using conventional lumber, we're using just simply an engineered wood piece, 1.5 inches thick, that's equivalent to that 2x lumber that's specified in the code. And this is perfect. This works just great. So that gets its fire from the outside. If anything happens on the inside, again, we're covered with that. So this is a good spec, it looks like. The only last piece I want to show you here is the firewall assembly again. So on the left-hand side, which you can see, this is actually a stairwell opening, so it's 2 floors high. We're just stacking walls on top of the other. No-brainer for that interior wall. The other wall that's in there, notice that the joist sets in it. So this is where things can get a little bit goofy. I mean, how you interpret this can vary. You can see the interpretation that this particular architect and building department came up with. So there is a provision, 708.4, has to do with continuity. That spot where the blocking panel is, you've got a joist bearing on top of the wall, you've got a blocking panel in between it. When you put those two together, when they're wooden I-beams, you end up with a gap, right? Well, that gap now, is that legal or is that not legal? Should that be stuffed with insulation? Would that be considered adequate as fire blocking or draft stopping? Or should that in fact be a solid piece of wood? Should they put a piece of 1.5 inch rim at that spot too, so that you have a full 1 hour both sides? Again, this was the interpretation that was taken for this particular project. It may not be where you are. So I'll leave you with this. When it comes to walking through here, it's a fairly straightforward process, right? You're looking at your occupancy, you look at your type of construction, you go in to check what your allowable height and square footage is. You look at the chart that has the ratings for the various building elements, and then you've got a whole grouping of additional items, the exterior walls, partition walls, and so on. So obviously there's going to be lots of differences, structure to structure. I didn't bother to try and go into all the varieties of fire issues here. We're just trying to hone in on these couple because there's a lot of other pieces we'll address at a different time for this simple structure. I think we've got it nailed. Now let's go out to the project site, see these in a little bit more detail, and answer probably a few of your questions.